The objective of this lesson is going to be very, very similar to that last lesson. Last lesson, our objective was to learn how to simplify radicals, cubed, or I'm sorry, simplify radicals with an index of 2 and 3, cube roots and square roots. This time, we're going to simplify radicals with variables. So the process is going to be very, very similar to what we've just done yesterday. So this will be a nice little refresher for yesterday's material, and it will be a great way to add in something new with what we already know. And like always, if you have questions at any part in this whole thing, come back to the Zoom chat, ask, and we will get you good and right. All right, let me full screen this. All right, so since our objective is the same, our essential question is going to be pretty similar. The only difference is that in this time, we're going to add in the variables. So this is going to be how can I express square, can't type, SQUAR, and cube roots with variables. That's the difference right there, with variables in simplest form, in their simplest form. H-E-I-R-S-I-M-P-L-E-S-T, simplest form. All right, how can we express variables, or how can we express cube roots and square roots with variables in their simplest form? That's going to be the goal for today's lesson. All right, and so everything else for the most part is going to be the same. I'm not going to spend a ton of time going over exactly what we did yesterday, since everything is pretty similar. But what I will do is use the information that we did yesterday to help us get kind of caught up and up to speed in case you didn't quite grasp everything. All right. So we're going to start with this first example where it says, recall for numbers that aren't perfect. That means we can't take the square root without having something left over. We can't take the square root and have it be a whole number. So if you typed it into Desmos and you type the square root or the cube root, you'd get a whole number. If you do get a whole number, that means it's perfect. And this is saying when we have numbers that don't result in a whole number, once we take that cube root or that square root, for numbers that aren't perfect underneath the radical, we use prime factorization. That's the thing with the line, okay? The steps will be almost identical if we have variables in the radicand as well. We have variables in that house, okay? Before we were just dealing with numbers in the house, and now we're going to look at what it looks like to have variables in the house as well. So for our first example, it says the square root of 48x cubed. When we go to do this, remember on this little porch piece right here, just outside the house, if there's nothing written, then we just know that's going to be a 2. That's always going to be our index. And our index tells us how many in a group. All right. That tells us how many in a group, how many we have to have before that group can leave the house. Okay, so let's actually go ahead and go through all this. The steps are there in case you don't quite remember them. But for the most part, I'm going to be using this as kind of an example and not go step by step the way it has it in the steps until we get to the variable portion. So we start off with our line. Ooh, not so straight. And then we have 1. We start with 1, and then we start with 48. All right, we start with 1, and then that helps us to understand that when we're over, we're going to have a 1 on the other side. We start with 1 on the left, and we end with 1 on the right. Okay, so we have 1 on the left, and then our next thing is going to be to divide by the next bit. This is even, so we can use a 2. So 48 divided by 2 leaves us with 24. Then we have another even number, so that's going to be another 2. 24 divided by 2 leaves us with 12. 12 divided by 2 leaves us with 6. 6 divided by 2 leaves us with 3. And then here's where we got to change it up because 3 isn't an even number. We have 3 divided by 3, and that's going to be a 1. We started with our 1, and we worked to our 1. So my next step here is going to be to draw my radical again, and then put these numbers on this left side, these numbers here on this side. All these numbers are going to go as the radicand for this next step. And let me scroll up just a little bit. So we end up with 1 times 2. Don't forget to write out that times. That's really important. These things are being multiplied together. 1 times 2 times 2 times 2 times 2 times 3. And I'm just going to check it. 1, 2, 2, 2, 2, 3. Yep. 1, 2, 3, 4 twos. 1, 2, 3, 4 twos. 1, 3. And then here's where that slightly new part comes in. We're just going to write out. We have these x's right here. We're going to write these right out behind it. This exponent tells us how many times we're going to write it. This x has an exponent of 3. This 3 right up here. So we're going to write that out. So times x times x times x. Now remember, this index of 2, this number that was out on the porch, tells us how many we need to have a group before they can go out. I see I have a group of 2s here. Actually, I'm going to circle these in a different number, or a different color, I mean. Purple. There we go. I have a group of 2s here, a pair of 2s here. That's going to come out. This pair of 2s is going to come out. And then I have a pair of x's that will also come out. So all these things will come out. And remember, we always have to multiply these things that come out. And then we also multiply whatever stays in as well. So these come out. We have a 2 as one pair times the 2 as from this other pair times the x from the other pair. And then what we're left with in this radical as our radicand is going to be this 1 times this 3 times this x. All right, those things don't have pairs, so they stay inside. They don't go out at all. And now becomes that we get to that simplifying portion where we're just going to write everything out fully solved. Let's do that in black. Oops. All right, 2 times 2 is 4 times x gives me 4x. And then we have the square root. 1 times 3 is 3. And then times x is x. All right. That's the only difference. We write out the ordered pairs. Okay. We write out the ordered pairs. That's what step number 2 says. Write the prime factors and variables and the exponents and the derivatives to how many times to write them. That's the new part. This portion here, let me underline that. So when you're going back through and looking at the notes, here's where we cover the variables. Step 2 in lesson 2 tells us what to do with the variables. Everything else is the same as it was that last time. So let's do another example. Hopefully I don't run out of space on this one, but I will do my best to keep things in line. For this one, when we get started, we always want to write out our index because that tells us how many we're going to need in a pair or we're going to need in a grouping before we can pull them out or before they can leave the house. So this one has nothing written here. And so that means it's always going to be a 2 if there's nothing written. And so this is how many are going to be in the groups. So we start with our 180. You know, I'm going to zoom in just a little bit more to help me write a little bit neater. 400, is that going to be too much? That should be good. All right. We start with 1 on this side and 180 on this side. And then we go through it the same way we've been doing. That looks like 188, not 180. 180. All right. So 2 into 180 gives me 90. 2 into 90 gives me 45. And here we have to change it up. 45 is an odd number. Like what I can think of that works with that. Going to be 5 goes into 45. How many times? 9 times. And then we see that 9 is going to be a perfect square. So we end up with a 3, then a 1. Or 3 goes into 9 3 times. And then we have a 3, I'm sorry, right there, and then a 1. All right. So now we write these things out again in our prime or under the radicand, under the house, in the house, however you want to say that part. I'm going to write all these things out and include our variables. So this is going to be a long, you know what? I wonder if I can just type that part. I'm going to try typing it because that might work a little bit better. So when we type this, insert symbol, and I don't see the square root under here, unfortunately. So I might just have to, is that it? There we go. That's it right there. In this square root, we're going to have 1 times, 1 times 2 times 2 times 5 times 3 times 3. Okay. And if you guys are trying to figure out where to get the square root, I hit the pi button where it says insert symbols. And then on that 1, 2, third row is where it is. It's like a check mark next to an X. All right, so now that I have my numbers written out, I now need to write out my variables, the number of times that they have that exponent. So this exponent for the X says 5, so I'm going to write that out 5 times, okay? So times X times X times X times X, 1, 2, 3, 4 times X. And then I got to do my Y 4 times Y times Y times Y times Y. Almost ran out of space there. And the reason we do this is that it helps us keep track of what pairs need to come out. All right, so even though I did just type that out, I'm always going to go through and check to make sure I got everything. I have 1, 1, 2 2s, a 5, 3, a 3. Then I'm going to count my X's and Y's. 1, 2, 3, 4, 5. Yep. 1, 2, 3, 4. Yep. And now I'm going to start circling my pairs. Okay. This index of 2 tells me that I need to have 2 numbers in the grouping before they come out. So I have 1, got a pair of 2s here, pair of 3s here, pair of X's here, pair of X's here, a pair of Y's here, and a pair of Y's here. All right. So all that looks kind of confusing, but I promise you it is very, very, very doable. There's a mouse at. All right. So now we're going to write out this next portion where we write out our actual answer. I haven't done purple yet. So we have this 2 times this 3. And the way we do this part, we're just multiplying each of these pairs together. So I multiply my pair of 2s, I multiply my pair of 3s times my X, this pair of X here, times my X, which is this pair here, times my Y, which is this pair here, times my other Y, which is that last pair. All right, so I've gone through, I've done that. And what I'm left with is this 1, this 5, and this X under the radical. And I can't forget that. I have to include that. And we get with a 1 and an X. All right. And then now that we've got all that done, I'm going to go to the side to save space. We'll multiply all these together. We have a 2 times a 3, which is a 6. Then we have X times X. X times X isn't going to be 2X because that would be adding them. This is, however, is going to be X squared, X raised to the power of 2. And then we have this Y times Y, which will also be Y squared. And then we got to keep that radical. Square root of, did I really write 1X? That shouldn't be 1X. That should be 1 times 5, which is 5. That should be 5X. Okay, that was a mistake. Hopefully I didn't trip anybody up too bad. But the rest of this will go pretty much exactly like this. So I think there are 3 examples left. Once again, like we did with the last classwork, there are 2 examples left in the summary. So like we did with that last classwork, go ahead, work on those 2 examples. If you get stuck with something and you need some help, come back to the Zoom chat. I usually go through and I message everyone on securely to see if you have questions, but come back to the Zoom chat if I haven't gotten to you or if I haven't messaged you yet. Come back to the Zoom chat, ask your questions, and then get working on the classwork, okay?